So we've already talked about transitive property and addition property. What did the transitive property before say? If A equals B and B equals C, then A equals C, right? So there's what's called the transitive property of inequality, which basically just does this. It takes these equal signs and says if A is less than B and B is less than C, what has to be true about A and C? Now, if I'm A, she's B, you're C. I have less apples than Emma does. Emma has less apples than you do. Laura, who cares? So what's the relationship between the number of apples I have and your apples? You have more apples than I do. So then C has to be bigger than A. Right? So that's called the transitive property of inequality. We also had an addition property where you can, if A equals B, then you can add a C to both sides and it still be equal, right? What do you think the addition property of inequality is then? A plus C is less than B plus C if A is less than B, right? If A is less than B, then A plus C is less than B plus C. Yes? So basically what we're going to start talking about is all inequalities. Like what's less than what. By the end of the day today, basically what we got to get into is we're going to start talking about like sides of triangles, angles of triangles, putting them in order. Which angles do we know have to be equal to each other? Or which ones have to be less than others? For example, we already have a theorem about exterior angles. What was that theorem? What did that say? Measure of angle 1 plus the measure of angle 2 has to equal 4. Like we've already established that as a fact, right? So what does that mean about the measure of angle 1 compared to the measure of angle 4? Doesn't 1 have to be less than 4? Sure does. And so does 2 has to be less than 4. Right? Because if 1 and 2 add up to 4, well, don't they both individually have to be less than 4? So again, the goal today is going to be, when I look at angles, which angles can I look at and go, I don't know what it is, I don't know what angle 4 is, I don't know what angle 1 is, but I do know that 1 has to be less than 4. Sure. Make sense? Now another thing we've already kind of talked about is just within a triangle, looking at sides and angles. How do you know what side has to be the biggest and what side has to be the smallest? Like if I give you this drawing and I say this is 40, this is 60, and this is 80. Do I know for a fact which side has to be the biggest side, which side has to be the smallest side? Which side is going to be the biggest? A what? AB? Why does AB have to be the biggest side? Because it's opposite of the biggest angle. And what angle has to be the smallest? Or what side has to be the smallest? BC? Because, again, it's opposite of smallest angle. Smallest angle has to be opposite the smallest side and vice versa. Smallest, if I know this, if I have side lengths, we'll just say this, quick 30, 60, 90, let's do this. What angle has to be the smallest angle? Angle A is the smallest. What's the biggest? Angle C? Is it because it looks biggest? No, it's just because it's opposite the biggest side, right? All right, everybody take a look at page 348. The hardest part of some of these is not just finding some angles that are bigger or less than. The hardest part of these is actually going to be, can I find all of the angles that are bigger or smaller, kind of thing. So everybody look at the top of page 348. I don't have my thing hooked up. Oh well. We'll just look at that. All right, so page 348, top of the page. Wave. I moved too fast. There you go. Follow me. Sometimes my cat likes speed and can't keep up. Number 1. What angles have to be less than angle 4? 1 and 2? Everybody agree? Easy? How about number 2? Which ones have to be bigger than 7? 9 for sure. 5 for sure. Anything else? Well, I don't necessarily know anything about 4, and actually I don't know anything about 6. But is there an angle that's also equal to 5?
3.
So if 5 has to be bigger than 7, 3 also has to be bigger than 7 because they're vertical, aren't they? So we can use that one. So the answer number 2 would be 3, 5, and 9. Again, the hardest part of these is not just, can I find an angle? Like everybody looks at number 2 and says, oh, number 9, right away. Angle 9. But can I find others as well? How about number 3? Which angles are bigger than angle 2? 4, yes. 6, yes. Anything else? 9. Hey, Brad, how we doing? Now, number 4 is a tough one. Which ones are less than 9? 6, 7. Well, I don't know about 5. But here's kind of what I want you to look at. Angle 9 is down here at the bottom, right? So these two angles for sure. On that inside of that first little triangle, which was what, 6 and 7? Is that the only triangle where that's an exterior angle of it? Is there a different triangle that might be bigger? What angle is this up here? 1. And what angle is this down here? So doesn't 9 have to also equal angle 1 plus 2 and 7, right? Yes? So what does 9 have to be bigger than? All three of them. It has to be bigger than 1, has to be bigger than 2, it also has to be bigger than 7. So the answer number 4 would be angle 1, angle 2, angle 6, and angle 7. All right, yeah, and 4. Yep. Are we good? All right, number 5. What angles, put them in order. What's the smallest angle? A is the smallest. What's next bigger? C, and then the biggest? B. And then how about number 6? How would you put the sides in order? What would you have to do first? Okay, how do you figure out the last one? So subtract those from 180. So 180 minus, what are the two angles? 47 and 46. and 87. So I got 47. So what side is going to be the smallest side? LK. Then what's next? JL. And finally, JK? Yes? Make sense? So again, two things you get right now you got to worry about is biggest side of any triangle has to be opposite of the biggest angle, smallest angle opposite smallest side. And if I have an exterior angle, we know it has to equal those two added together. So it has to be bigger than each of them individually. Yes? So far so good? All right, real quick, take out a sheet of paper.